Okay, let's confront the problems in our 2D contour toolpath. Problem 1 is that I'm cutting too low. If I brought my tool down this low, I would mill off the top of my vise. That's problem 1. Problem 2 is also that I'm coming too low, but too low for a different reason. Look at my tool and notice how it has a gold portion that then becomes a gray portion. The gold portion indicates the part of my tool that can actually cut. The gray is the shank of the tool. It can do no cutting, but I'm bringing the tool so low that I'm asking the shank to cut metal away. And that's why Fusion is turning the entire tool bright red as a warning and turning the stock bright red, saying, for this metal to go away, something impossible must happen. The shank of the tool, which has no sharp edges, it's just a round, smooth, cylindrical shank, is going to have to smush this metal out of the way, and that's a bad thing. You're bringing the tool too low. So let's fix it, partially in the Heights tab and partially here in the Passes tab. The Passes tab controls how your tool passes across the material. So let's start there. Check this box near multiple depths. It'll reveal some parameters about cutting away material using precisely that, multiple depths. For now, we're just going to change this one parameter, maximum roughing step down. Let's set it to be 1/2 inch, 0.5. This tells Fusion that it is only allowed to remove material 1/2 inch at a time. Click OK and you'll see a very different tool path. Now there are 2 blue lines, 2 cutting passes around the material. The first one is 1/2 inch down, and the second one is at our final height. And if you simulate this tool path, now you'll see the tool come down to our first depth, cut all the way around the contour, retract, and then come down to our final height and cut all the way around again. And now Fusion is more happy. The tool is not bright red, and the stock is not receiving a bright red stripe. Good, but our overall height is still too low. We're still going to mill down into our vise, which is trying to clamp onto our material down there. So exit the simulation and double-click on your 2D contour toolpath to edit it, and now come to the Heights tab. At the bottom of the parameter list is the one that we're going to think about today, the bottom height. Notice how it's built. It is built from the selected contours. That's what we selected as the closed chain, and it's offset by 0 inches. Well, let's change that. Let's offset it by 1/4 inch, 0.25. And look at that, we've now lifted up at the lower of our 2 tool paths by 1/4 inch. And if we simulate it, we can see that our first pass still comes down 1/2 inch, our maximum roughing step down, but the second one now doesn't quite go down as far, leaving us enough room to clamp onto material in the vise. And look at this, not only did we remove the side walls of the cube, but we removed the material of those tiny little 10-thou chamfers that run vertically up and down the cube. But we did not yet create the chamfer that runs around the top 4 edges of the cube, so let's make that next. Come on back to this menu of 2D toolpaths and come down to 2D chamfer. Once again, we're going to start in the Tool tab, and we're going to select a tool, and we're going to pull it from the Cloud Makerspace tools. This time we're going to pull the 1/8 engraver chamfer tool, tool 12. This tool has a 1/8 shank, it's pointy, and away from the point out to the shank runs the angle of the tool at 45 degrees on either side. And we're going to sneak this tool up to those top 4 edges and use the shoulder of the tool up from the pointy tip to cut that beautiful 10-thou chamfer. After choosing the tool, confirm that its surface speed is set to about 163 surface feet per minute, and check that we're only asking this tool to cut 1/1000th of an inch of material per tooth. Then come to the Geometry tab and notice how Fusion is asking us for a contour selection, just like the 2D contour tool path. And we're going to select this contour around the bottom of the chamfer. And once again, make sure that the red arrow that indicates the outside is on the outside of your tool path. Otherwise, your chamfer is going to plow through the middle of your cube and snap off. Click OK and let's see what we got. I'm seeing no blue toolpath line and a warning over by the toolpath, so double click on that orange triangle to read the warning. Make sure to read these word for word and try to make your best guess at what they mean. This one says, warning, empty toolpath. If you are machining a chamfer that is modeled try setting the chamfer width and chamfer clearance to 0. Is our chamfer modeled? Yes, it is. We modeled it back in the Design tab. We modeled it to be a 10 thou chamfer, and we can see it on the gray model. So let's try setting those two parameters to 0. In your Passes tab, here they are. The chamfer width is already 0, and the chamfer clearance is not. So let's set it to 0, and there we go. Now we have a toolpath. Why this complication? There are lots of ways to build a chamfer, and Fusion doesn't know that we chose the path of modeling our chamfer back at the design phase. Okay, look at what we've built. Our setup now has a facing operation to take the top off our material, followed by a 2D contour toolpath with multiple depths to take off the sides, and coincidentally to create those chamfers on the vertical edges. And lastly, we've got a chamfer toolpath to put the chamfer on the top 4 edges of our cube. Good. Hold down the Shift key to select the 2D contour and the chamfer, the two operations that we haven't actually finished in the mill yet. Then from the Actions menu, choose Simulate and drag through your simulation to see Tool 1, the 3/8 end mill, perform the contouring operation, and then Tool 12, the chamfer tool, scoot down and nip off the top edges of our cube, creating those chamfers. Good. This is absolutely everything that we can reach at this point in time. Next up, we're going to talk about how to flip it all upside down, find it again with precision so that we can mill the bottom.